Alright guys, this time we are doing 9.4 and we are doing key features. You should have been doing key features for the last couple of years. We might involve transformations in this to help us out, or the calculator. So make sure you have a graphing calculator with you. First thing we're going to do is write the definitions of all those key features and what they're talking about. So I pre-wrote them, so I will try to explain them slowly. Otherwise, I would pause the video so you can write things down. So first we have our domain and range. If you remember, domain are all the x values, so that's how far left you go to how far right you go. Range is the y values, how far down to how far up. And don't forget, when we're doing domain and range, we have to think about parentheses or brackets. Does it include it or not? Next, we have our intercepts. So, X-intercept is where the graph crosses the x-axis. That means y will always be 0. The y-intercept is where the graph crosses the y-axis, and the x will always be 0. I want you guys to make sure that when you write an x and y intercept that you're writing it in a coordinate pair. Okay. If you were to solve for one of these, we would set this equal to 0 and solve, and this one we would put in 0 for x and then solve for y. Next, we have a max and a min. We're going to talk about relative max, relative min. Where is it a high point? Where is it a low point? Now, a max and a min really indicate that it's going from increasing to decreasing. Where minimum is decreasing to increasing, it's a low point. An absolute max min, which is not in our notes here, is when it's the highest point or the lowest point. And again, those need to be in a coordinate pair. Now, increasing, decreasing. So let's keep in mind and constant. We'll go all the way down on this one. We need to remember that we are looking from left to right, just like we read. And if it's increasing, our graph is moving up. Our decreasing, our graph is moving down. Then constant is it's going horizontal. Let's remember that when we write intervals, so write intervals in x values. Okay, positive and negative. So positive is where it's above the x-axis. Sorry guys. And negative is where it's below the x-axis. Okay, lots of times I would circle where it's above, where it's below. End behavior, we've done end behavior earlier this year. It's talking about our limits, so we want to write it limit as x approaches infinity, because that's all the way to the right is infinity, where left end behavior is where it's going to negative infinity. So I'll put that question, where is the graph going? Okay, so now let's talk about symmetry. Okay, symmetry. So it's an even function if it reflects over the y-axis. So I gave you an example here. An odd function rotates around the origin 180 degrees. So I give you another one. and a couple neither. So just don't say no symmetry, just say neither, guys. So as you can see, I use the examples of the even and odd, but I move them. So this no longer is reflecting across the y-axis, and this is no longer rotating around the origin. Okay, and then we have a couple over here. Okay, let's go on to our first example. Now with this one, we're not in the form of where we did our transformations 2 sections ago. So what we're going to have to do is use our graphing calculator for this problem. So we want to go to y equals and plug this in. So we get negative x cubed plus 2x. As you can see for the window right now, I'm just doing it at negative 10 and 10 all the way through, just basic. And we'll see if I have to go in closer or not. I would go in closer, guys, because we want to really get into this area. So let's break it down to negative 5, 5. It looks a little bit better. So the first thing I'm going to have you do is just sketch out this graph. Okay. So it looks like we're crossing here and we're dipping up. Okay. And then what we're going to do is we're going to find all these points on the graph. So of course this is at 0, 0. We want to find all these x-intercepts here. So there's a couple ways we can do this. You can do second trace, go to 0, but then you would have to be on the left side, enter, right side, enter, and as you can see I get negative 1.414. Let's go out 3 decimal places. Or we can do it the other way by saying y2 is 0 and then second trace, find where they intersect. So that's going to be up to you. I'm going to go to this next intersection here. 1, 2, 3. And I get on this side, I get 1.414. Okay, a couple other points we need. We need this high point and this low point. Okay, that's our min and our max. So if you go to second trace, we can go, I'll do the max first. Go to max, enter. It says left bound, which means we want to be on the left side of that high point. So see how my flashy dot is on the left side? So I go enter. Now it's asking me for the right side, enter, and then enter one more time. And it shows us that our max is at negative 816, comma 1.089. I'm going to do the same thing again, but with our min. So let me get down. Oops, let me get down to that. It wants to be on the left side of that min. Enter. Right side of that min, and then get negative 0.816, comma negative 1.089. All right. I think I got most of these points. All right, so the domain. So how far left does it go? How far right does it go? If we look, this arrow tells us we're going to continue this way. This one says we're going to continue this way. So our domain is negative infinity to infinity. Our range, how far down, how far up, negative infinity to negative infinity. You could also think from last section that, are there any issues we have with this function? No, there's no variable in the denominator, and we're not dealing with an even root. Okay, these are all of our points. So x If you look, how many times does it cross the x-axis? There are 3 of them, so make sure that you put all of them down. Now, because our x-intercept is 0, 0, it also means that that is our y-intercept. You can just put that once, guys, since I have this in the same category. Also, our max and our min. When you do your max and min, make sure you label it. So we have a min at negative 0.816, comma, negative 1.089. And we have a max at positive 8.816, 1.089. Okay, increasing, decreasing. You want to be careful. Think of this. I'm going down, up, down. So remember, increasing is where we said up. So we're going up from here to here. Does everyone see that? But what values are we supposed to use in our coordinate? We're supposed to use our x value. So I'm only going to use that 0.816 value. So our lowest is negative 0.816, and it keeps increasing to 0.816. Decreasing is where it goes down. And what do you know? I see 2 parts that it goes down, right here and right here. So let's look at that first area. That first area where it goes down has an arrow on it, which means it starts on the left side, so it's negative infinity. It keeps going down to this point right here. Well, what's the x value right there? Negative 0.816. We have another decreasing, okay, right here. It starts decreasing at this point. That x value is 0.816. And it decreases all the way to, and remember we're using our left and right. It goes to the right, so it must be infinity. Okay, positive, above and below the graph. Okay, so I'm going to cover the bottom part. There are 2 parts that it's above. Okay, so I'm going to have 2 separate intervals. So let's do that first one. First one has an arrow on it, so that's negative infinity because we're starting at the left, and it hits all the way at this point. Right, that's where it's above. The x value is negative 1.414. And where is it positive again? Well, look at the x values here. It goes from 0 to 1.14. Negative, cover the top. Where's the first part where it's negative? This u here. If I see the x values, I get negative 1.414 to 0, goes all the way to 0. And where does it start again? At 1.414. And it keeps going down all the way to the right, which is infinity. And behavior. So right here it says x to negative infinity, which is our left, and then positive infinity is our right. So on the left side, which way is that arrow pointing? It's pointing up to infinity. On the right side, where is that arrow pointing? It's pointing down to negative infinity. Now remember, our choices for symmetry are even, odd, and neither. Even means it reflects. Odd, it rotates. Neither means none of those. What does it do? It rotates, so it's odd. Let's do our next example.